page 363, number 10. Let's see what it says here. A 10-kilogram block lies on a smooth ramp that is inclined at 30 degrees. Okay, so here's a picture of it. There's the block. The incline is 30 degrees. What force parallel to the ramp, so parallel to the ramp, would prevent the block from moving? Okay, assume that 1 kilogram exerts a force of 9.8 newtons. So we're going to do that for the rest of the course. Okay, so 1 kilogram exerts a force of 9.8 newtons. Okay, so this is a 10 kilogram force, so it's going to have 98 newtons down. Okay, so gravity acts down. So now we need to figure out what force that would be down here. So we're looking for the equilibrium force that would be required to stop that brick from moving. Okay. So I'm going to draw this out. I'm going to draw a nice big picture so I can work with the diagram easier. I'm going to put the block here. Okay, those of you studying physics probably realize that this is very similar to what you've been doing in physics, or what you've done. Okay, so then you have a force going straight down. Okay, and that's the force due to gravity of that block. It's 10 kilograms. Okay, 10 kilograms, which means 10 kilograms down, which means the force down is equal to 98 newtons. Okay? 1 kilogram is 9.8, so 10 is going to be 98. Now we have to figure out what the force is down the ramp. Well, that block is not going to go straight down unless that ramp is really weak. Right? Okay, so we're looking for an equilibrium force to hold this block onto the ramp, and we're also going to have to break this force up into components. And there's going to be two components here. A component parallel to the ramp and a component perpendicular to the ramp. We could probably think of this like an XY axis. Okay? We like to look at it more like this though, right? We want to think of the x-axis as horizontal and the y-axis as vertical. So you kind of have to twist your head a little bit when you're looking at this, and then you want to break it up into components. Okay? So I'm going to draw that diagram off to the side here. We've got a 10 Newton force going this way, sorry, a 98 Newton force going this way. Okay. We want this component, and we don't want this component, but this would be the other component. Okay. And the sum of these two vectors, the vector that is parallel to the ramp and the vector that is perpendicular to the ramp, the sum of those two vectors give us the 98 newtons. Okay? So I'm going to call this FD, which is the force down the ramp. Okay? And I'll call this one FP, which is the force perpendicular to the ramp. Okay. We know the angle here is 30 degrees. Now, going back to this diagram over here, we've got that triangle seems to fit in right here, where that's perpendicular. Okay? Because that line's perpendicular to this ramp, Well, where would this 30 degrees transfer to? Well, that's going to be a similar, this 30 degrees is going to create a similar triangle to that one if we draw a perpendicular down here. Okay, so spin that around. This is also 30 degrees. Okay. The other way to think of that is if I continued this line straight down here, well, I've now got a right triangle made with the ramp. This is 90 down here. This is 30. Well, then this angle here is going to have to be 90 minus 30 in order to add up to 180. Okay? So this is 30 in this triangle. This one in here is going to be 60. Okay? Which means in this triangle here we've got 30 and 60. This is the right angle. Okay? So the force going down will always be the hypotenuse of this right triangle. The force going, not down the ramp, the force going straight down. Sorry. Okay. So now we want to figure out what FD is. And we really only need the magnitude, because the question asks for what would prevent the block from moving. Okay, so the force that prevents it from moving, we know the force is going to have to be up the ramp. Okay, and so that's what we're looking for, what the force is down the ramp. So FD, I'm just going to leave it without the arrow on top so that I can just find the magnitude. So in this triangle here, we've got cos of 60 is adjacent over hypotenuse. Okay. Sine of 30 is opposite over hypotenuse. So we can use either one. We can use the 30 degrees or the 60 degrees. So if we write sine of 30 degrees equals opposite, which is FD, over hypotenuse, which is 98. Okay, we'll be able to solve for FD that way, or we can write cos of 60 degrees equals FD over 98. So FD then equals 98 times sine of 30 degrees, or it equals 98 times cos of 60 degrees. Okay. And when you put either one of those in your calculator, you're going to get what? Pardon? 49? 49 exactly? Okay. So 49 newtons. Okay. So therefore, the force up the ramp that would hold it, okay, you write, therefore, the force up the ramp that would hold the block would have to be 49 newtons.